In these follow-along labs, we will set up the position servo for external reference in torque, velocity, and position modes. Before attempting to perform any of these labs, ensure the motor is free to spin in any direction with no load attached and without restrictions. These labs build upon each other, so it is recommended to perform them in sequence. Reference can be set to either external or internal. An external reference can originate commonly from a PLC, a motion controller, or a master encoder. An internal reference originates from the drive's internal variables. These typically are manipulated by the internal user program, but can also be written to from a master device over a communications network. There are two basic control architectures for systems: centralized control and decentralized control. Decentralized control, simply put, relies on devices performing logical actions on their own and exchanging data amongst each other to perform as a system. Centralized control relies on a centralized controller to make all logical decisions and issue commands to the individual devices. One such system is an external motion controller. These systems will read the buffered encoder output of the drive to solve a position loop and command the drive, giving it an analog torque reference. This lab will cover setting the drive to torque mode with an external reference. This is the E94ZAT-ST01 test board. If you have a sales demo unit from Lenze, this board should be included in the setup. For this lab, we will be using input A3, which is the top switch on the board, and analog input 1, which is the bottom analog potentiometer. If you do not have a Lenze sales demo unit, you can also duplicate this lab, wiring a digital signal to input A3 and a 0 to 10 volt DC signal into analog input 1. Wiring diagrams are provided in the Position Servo user manual. First, connect to the drive with MVOB. Select the parameter selection of the navigation tree, and then set the drive mode to torque. Next, set the reference to external. Select digital I/O from the navigation tree. Now, set the enable switch function to run. Now, turn on the enable input, which is input A3. Again, this is the top switch of the test board. The drive is now enabled and producing torque. Use analog input 1, the lower part of the test board, to change the torque command to the drive and note the motor response. Note that when the torque commanded exceeds the friction, the motor will accelerate and run away until the drive faults with an overspeed fault, FOS. Clear the fault by disabling and then re-enabling the drive. You can adjust the commanded torque scale, amps per volt, using the analog input current scale parameter on the analog I/O selection of the navigation tree. In velocity mode, an external reference commands a motor speed in RPM. We will now walk through configuring the drive for this basic function. Under the parameter selection in the navigation tree, change the drive mode to velocity. You will leave the reference set to external as used in the previous lab. Turn on the enable input, input A3, and use the lower pot to change the analog input 1 signal. Note the motor's reaction. The analog input velocity scale parameter on the analog I/O selection of the navigation tree is used to change the scaling of the command signal. Go back to the parameter selection of the navigation tree. Here you can find the velocity mode, acceleration, and deceleration limits. You need to select Enable for Enable Accel Decel Limits for these limits to function. These settings only apply to the drive while it is in velocity mode. The analog input offset command, the button with the arrows on it, changes the analog command 0 value to whatever the current analog input value is. To illustrate this, set the pot for analog input 1 halfway. Then click the Analog Input Offset button. You will notice now turning the pot down causes the drive to change directions. This feature is useful in analog control applications where the drive needs to run in both directions, but the analog input control can only produce a 0 to 10 volt DC signal. Set the command to 5 volt DC, then click the Analog Input Offset button. The change is stored to the drive's non-volatile memory. Some systems suffer from residual voltage on the analog signal wiring. Set the command signal to 0 volts and select the Analog Input Offset to resolve this issue. To simulate this, turn the pot all the way down on your unit and again click the Analog Input Offset button. Let's watch the effect of us enabling the accel-decel limits in velocity mode. Select Tools in the navigation tree. Then click on Oscilloscope. In the oscilloscope window, set the signal for channel 1 to motor velocity and the signal for channel 2 to analog input 1. Click Run on the oscilloscope window to start the data display. Now, enable the drive using input A3 and change the analog input 1 value by manipulating the lower pot on the test board. Now, note the drive's response. External reference for the drive in position mode is either a master encoder or a step and direction signal. We will configure a master encoder as the external reference in our next lab. Electronic gearing is easily configurable off of the position mode external reference. We will also configure this during this lab. A master encoder must be a 5 volt DC encoder. This is the E94ZATB02 terminal block option module, which is commonly used in most applications. Pins 1 through 4 are used to wire either the master encoder or a step and direction signal to the drive. Differential signals are preferred for either a master encoder or step and direction reference. Single-ended wiring may be used, but is not recommended. This diagram illustrates wiring the enable input, input A3, through a switch using the drive's built-in 5 volt DC 100 milliamp convenience power supply. For a master encoder signal, connect A positive to pin 1, A negative to pin 2, B positive to pin 3, B negative to pin 4, the encoder's common to pin 5, and the encoder 5 volt DC power input to pin 6. The Lenze sales demos have a master encoder already wired to the test board. Select the parameters from the node tree. Leave the reference set to external and set the drive mode to position. If drive mode is not accessible, grayed out, you still have the drive enabled. You must disable the drive in order to change drive mode. As we are using a master encoder input in this lab, set the master encoder input type parameter to master encoder. The SD setting will be used for a step and direction signal. Now change the master to system ratio. Remember, this is raw counts from the master to desired raw encoder counts out of the drive or system. Remember, the master encoder may not be the same PPR, pulses per revolution count, as the encoder of your motor, so you'll want to check this to understand the operation of the drive from this lab exercise. Enable and disable the drive, rotate the master encoder wheel, and watch the response of the system.